Punchline of this whole analysis is that the benchmark provided by the social planner is not in general reached by the decentralized economy. So in lecture 4 today, we're going to talk about the last touches of the OLG model, the overlapping generations model, and its applications to macroeconomics and economic growth. And I'd like to use the OLG model of, as we've looked at it with capital, the diamond model, and apply that to sort of introduce a notion of that was popularized by Ramsey in the 1920s in his famous Economic Journal article, where he looks at the social planner, thinking about the long-term planning for the very, very long horizon, and this issue of what discount rate should be used to evaluate utility in the future. This is an important issue, especially with respect to policy, because all of us have finite lives, but the politicians that plan also have maybe the welfare of the nation involved, or some region or city, and in doing so, we'll be expected to plan for people who have not yet been born. So this is a very interesting issue in macro, especially with respect to growth theory, and will be the basis of much discussion in this literature. So today I'd like to review last week briefly. I'd like to spend some time thinking about that discussion as a motivation for the social planner. Again, setting it up, this problem of a fictitious agent acting on behalf of all future generations in a model with perfect foresight. So it's a very rarefied, idealized model, very simple in some sense, but offering quite a bit of complexity at the same time. We'll use this as a performance benchmark. So the idea would be to say, we know the market solution is the dominant approach to solving the problem of allocating scarce resources over time, but we'd like to still know what could we be doing wrong. Are there ways that we could intervene in a policy sense with appropriate taxes and subsidies to reach a better solution for everybody? And this is a difficult question to answer without getting emotional, and the discussion of the environment and the future of the earth, global warming, all has a very similar flavor. The idea, to what extent can somewhat selfish agents in any given time miss the mark in terms of hitting the right level of social action and social investment to provide for a better future for all generations. And this is a very interesting critique of the decentralized solution. So we're going to show basically that under certain conditions, the market gets it right. Some cases it does, in some cases it doesn't. In any case, it's going to be really rare that the market gets it exactly right, and there'll generally be two cases, two different types of inefficiencies. One will involve some sort of current sacrifice to reach a better outcome in the long run. So if there is policy intervention, it will be painful for some generations for some time. And then there's another notion in which the market is just getting it completely wrong, and the economy is accumulating too much capital and could actually make everyone better off by consuming a little bit more in every generation from now until eternity. And that's the so-called dynamic inefficient case. And the OLG model is very, very good at showing those two cases, and that getting it just right is rather difficult if agents are planning for themselves in a selfish way without any sort of intergenerational altruism. And on this basis, we can use the OLG model as a tool to think about policy. We can think about the efficacy of pension systems that are offered by the government as opposed to pension systems that are privately organized. I always think about Bismarck in the United States, Bismarck in Germany and the United States, FDR in the United States as being the prime examples of moves in the direction of more government intervening to provide a system of retirement insurance, or pension insurance as the Germans call it, or a pension system that takes individuals' freedom away, but gives them a bit of security in the long run, and gives the economy a certain amount of security in the long run. You can rationalize this type of intervention using the OLG model, and you can also show that it gets it wrong sometimes. It may make an economy worse off, and also we can finally use it to motivate intergenerational altruism as an alternative mechanism. If agents just don't care about themselves in their own lifespan, but also care about agents that are connected to them through a family, they might use the bequest as an instrument to influence future decisions. This is a limited instrument. It's not allowed, or it's not legal to have a negative bequest. Sometimes you can let your mind run free and imagine a world where you actually can, but to the extent that bequests can only be positive, does not prevent it from being used as a possible instrument to increase intergenerational utility, just through the fact that parents care about their children, generations born today care about future generations in some consistent way. So this is an interesting development that actually David Ricardo anticipated in the early 19th century. And Robert Barrow in the 1970s renewed this discussion in a very intensive way, and this is an extremely Nobel-worthy achievement, in my view, to revive the discussion of intergenerational altruism as being an offset, perhaps moving the economy back in the direction of the first best. But this is, again, a theoretical possibility, and there are lots of reasons to worry that the conditions required for the so-called Barrow Ricardian equivalence not to hold. Still in all, we're talking about benchmarks, and the social planner is a benchmark, Ricardian equivalence is a benchmark, and we should keep that in mind when we discuss real-life policy. So last time we discussed the OLG model in great detail. We kind of give you a notion of what models are supposed to look like. Models are supposed to be very well specified, very clear about what they assume and what they don't assume, and making it easy, of course, to criticize, and that's why we do this. We want to understand why the models predict something that may not be quite right, or maybe predicting something that may not be robust. We need to know the role of preferences, agents' personal feelings about consumption today and consumption tomorrow, agents' risk aversion, the curvature of the utility function, the rate at which marginal utility declines in increasing consumption. We need to know about there's no risk in this model, but we need to know a lot about those preferences. All the same, especially the rate of private discount. We also need to know about technology. How does the economy transform resources today into resources tomorrow? And the mechanism is a neoclassical production function with capital formation. So deferred consumption means savings for the future, means production for the future. And we also need to know how productive capital is in future periods. Agents have perfect foresight in this model, so we've ruled out making big mistakes. This could be criticized, but I think it's one of the more less severe or less noxious assumptions in this model. We also make the market assumption that markets are competitive. So wages represent the marginal product of labor, and the rate of return on capital has a lot to do with the marginal product of capital. And because agents save the resources into the next period, in the second period, agents that are old will use their entire capital stock that they own to buy consumption from young agents. So there'll be some net saving and dissaving going on within a period. But in the end, agents will have to save to replace capital that is depreciated. And if the economy is growing, capital will be naturally getting scarce over time. So there'll be more and more accumulation required by agents. So there'll be gross investment in this model as well. We looked at the decentralized equilibrium in this case. It's just a couple of equations, and there's a nice graphical representation of this equilibrium, which is convenient. I'm a big fan of graphic representation of economies to the extent that we can. Many economies have 3 or more variables, makes it difficult to represent the outcome in a two-dimensional space. But economics in the past, since Marshall or even before, have saw fit to try at least to reduce or to compress reality into a two-dimensional visualization that will help us understand endogeneity. What does it mean to be an endogenous variable, and what does it mean to have exogenous shifts in various parameters that we take normally as given? So this is kind of the approach we use with the OLG model. Many textbooks go right into the mathematics, the Benassi textbook, for example. But I am convinced that using the graphic tool will help us move to the mathematics more readily and again, distinguish between exogenous and endogenous variables, which is always important. Using this, we derived a golden rule, which is kind of the same logic that we had with the Solow model. The Solow model predicted that the economy has a mechanical savings propensity, and this mechanical savings propensity leads to a mechanically determined steady state. It turns out that being mechanical is not a really valid criticism because this model has endured for more than 60 years. The model is working and it helps us make some very sustainable predictions about development. It misses the point on a few things, but the golden rule is a very important statement which relates the rate of growth in the economy to and the marginal product of capital and the interest rate to population growth, to preferences of individuals and the like. In the Solow model, it was very simple. Phelps's idea was to maximize per capita consumption, which means you don't really have to care very much about preferences because we're just ignoring them. We're just going to maximize per capita consumption. Given the population growth, given the growth of technical progress, given the depreciation rate in the economy, given the production function, this gives a very clear answer. Just maximizing the distance between the per capita production function and the capital widening line. This mechanical answer can be amended, can be extended, and the notion of the OLG model in this part of the course is just to help you understand why that's still a fairly clever thing that Phelps came up with in the 60s, which was that the rate of population growth, the rate of depreciation, the rate of social time preference have a lot to do with the optimal capital intensity in the economy for a given production function. Okay, so we kind of drove that point home. It's a much more sophisticated point because it involves the rate of preference. It involves the rate of preference for the social planner, and in a decentralized economy, it would also involve the savings propensity of the private household, which is determined by private preferences, and these need not coincide. Okay, so in the planner's optimum, we have a really clear notion of a golden rule. I'll review that again, and then we can ask whether the private decentralized outcome actually meets the mark, and we showed that it didn't necessarily. There is one interesting case where it does, and we'll repeat that. We started to talk about policy analysis, and I'll finish that discussion today. I'll use that discussion as a springboard to think about intergenerational altruism, the notion that the OLG model is potentially too limited. If you have a generation which overlaps another and the planning generation in time 0 or time 1 actually takes the welfare of future generations that will be born in subsequent periods or in the next period into account, that will lead to a different type of behavior if the agent has a mechanism with which she can actually project her decision into the decision-making process of subsequent generations. So this is a very involved point, and it's spawned a huge literature. Those of you who are interested, I can give you references. One extension is to have many generations, not just 2 generations alive at one time, but you can have 20 or 30 in an annual model. You can have lots of different people involved. It's not amenable to graphical analysis. So clearly, it would require the help of computational facilities, computing facilities to do this problem. But it's not an insurmountable problem nowadays. The question is it interesting in terms of generating insights? And because these models are used in policy, I would submit that they actually are. The model is useful. Let's just review again. the OLG model is a model with micro foundations. So the notion is that we have a microeconomic model that drives the macroeconomic outcomes. It's a model that takes the point of Irving Fisher seriously. Agents plan over their lifetime. This Fisher model of optimal consumption over 2 periods was extended by Milton Friedman and Franco Modigliani. It's a very, very important part of the canon of macroeconomic ideas. We'd like to think that capital formation, the capital stock, is the main vehicle for doing this. The original Samuelson model that gave rise to the diamond approach that we're using in this course used money as the vehicle for savings. But actually, if you use capital to save, capital has a two-edged function, or a double function. It has the function of enabling the production of goods at any point in time, but it also gives agents the ability, due to capital's durability, to move resources into the future. So we're also able to make a link between the production function and capital, and the productivity of capital, and the rate of depreciation. And were depreciation to be complete every period, we have a Robinson Crusoe economy where you plant the grain, and the next period you have to eat it. There's no way to save it for another period. This is just a special case of what we're about to do. Okay, so we can extend this model to incorporate all sorts of other features that we're not going to do. In some universities in this world, you can actually take courses that spend a lot of time on this. So you can adopt the view that labor supply is endogenous, for example. So the agent doesn't supply just one unit, but can change labor supply behavior to respond to incentives that arise in the labor market. You can also adapt the model to incorporate uncertainty. Certain types of uncertainty may change agents' behavior. The second and possibly higher moments of the distribution of uncertainty could affect agents' savings decisions and labor supply decisions. You can add bequests, which we will do in a primitive way, but you can add unintentional bequests. Agents may save not knowing exactly when their time has come, and will lead to accidental bequests in equilibrium. So you'll have some capital stock being just accidentally bequeathed to future generations, but in the aggregate, these things kind of wash. You'll see possibly more saving in such a model. Some would say that's the reason Social Security and the Bismarck system of Sozialversicherung was instituted, was basically to eliminate this uncertainty of maybe saving too much, because of those people who sort of exit early will possibly regret it in some sense, if you can imagine that, at least have the feeling that they're saving too much. And that has the interesting implication that the economy as a whole will save less. So the economy is saving too much to compensate for risk that could be insured away, then maybe through the system of annuities or some government-provided system of Social Security, this excess savings could be eliminated. Okay, so these are extensions of the model. We don't have uncertainty at all in this model. This is really a perfect foresight model. Everything's planned along the certainty equivalent. Still in all, lots of implications. We talked about them already, and we'll repeat them again. So let's go quickly to the notation. We're going to use the little c to denote an individual's consumption, and C1 would be young people, and C2 would represent old people, both applied to period T. Okay, so a young person will coexist with an old person in this economy in different numbers. The economy is growing at rate little n, so there are 1 plus n times the population of the old in the young at any point in time. These young people will save, and they take a savings decision in period T. Under perfect foresight, they would save out of their income, which they earn by supplying 1 unit of labor to the labor market and earning omega. Having saved, the capital stock will be available in the second period and used in production, and will undergo a depreciation at rate delta. We can then define a gross rate of return, and that gross means +1, because the agents, when they divest themselves of their capital stock, they will also get the original capital, the original gross savings back plus some interest rate, which of course could also be negative, but in this model will generally be positive. And this capital R is accruing in T plus 1. So the agent will take the decision to save or not to save, to consume today and tomorrow in period T. For T equals 0 to infinity, they're different generations. You get to do this once, and then you get to enjoy the mistake or the good decision you took, and then you're out of here. And the rate of return, this gross rate of return, will be given by 1 minus delta plus the marginal product of capital per capita, which is would be a competitive market outcome. Okay, so we're already slipping in the assumption that wages and rate of capital rental rates reflect marginal products of these factors. Okay. Agents have impatience, private impatience, which is summarized by beta. Beta can be thought of as intrapersonal, meaning one person, one family. There's no intergenerational altruism yet, so it's basically how much do I want to weight my utility that I can derive from my activities today relative to tomorrow. And the discount rate we're going to use is beta, so it's 1 over 1 plus some private discount rate. This discount factor is not to be confused with the discount rate the social planner would use, or the implied social discount factor. That's the next line on this slide, which just basically says that theta is the rate of social discount or central planner's discount, and then the implicit factor would be just 1 plus theta inverse. I already mentioned the rate of population growth. Capital N is the population size, and for simplicity, we will just assume a full employment economy. I've said this many times. You can have all sorts of inefficiencies in the labor market which lead to unemployment, but it doesn't help the underlying OLG logic. So in the interest of Occam's razor, we'll just eliminate that aspect. Benassi, in his book, uses a generalized notion of the social weighting factor, which means that the social planner doesn't have to do anything. She could do whatever she wants. But if she has a discount rate, she's going to set Xi to a power of 1 over 1 plus theta. Okay, so she's going to use exponential discounting to weight present and future utility, and all people are treated equally, all generations are treated equally, with the exception of this theta. So theta is an arbitrary number, Xi is an arbitrary sequence, but Benassi sort of makes it completely general, because you might imagine governments changing. Some governments are more impatient. Maybe Italy has a change of government. But again, in a model with perfect foresight, these things all have to be foreseeable. But it's just in the interest of generality. We'll just keep that. But we'll not use it in this course. Okay, so again, the social planner is this individual that is standing above the sequence of generations from now until eternity, and is trying to make things as best as possible using some weighting scheme over time. Why do we care about that? Well, because we think the market equilibrium, the decentralized market equilibrium, might not always get it right. So this is a concession that Adam Smith, in all his wisdom, might have missed something. Okay, so there's a market failure somewhere. We know this from other courses, from microeconomics in general. There's a possibility of a market failure. Market failures can arise for many reasons, but in this case, the market failure arises because generations that will come to the market in the future have no ability to be considered at time period 0. So logically, there's no guarantee that the market outcome will reflect their best interests. And again, the logic is exquisitely applied to the environmental dilemma. Even if we have a world of perfect certainty, if people are selfish now, it may be in their best interest to ignore the consequences of climate change, because they're not going to be around to worry about it anyway. Okay, this is a fairly dark view of the world, and it's unfortunately quite accurate. So to the extent that people do care about their children or their children's children or some other people who have a longer lifespan, the world could be saved, but there's no guarantee that this will happen. Okay, so this raises the question that we will come back to later at the end of the lecture about discounting, the idea of whether it's even correct or fair or ethical to do this. And recently there have been many, many discussions of this issue. The correct social discount rate remains a very hot topic in not just environmental economics, but in general, but especially with respect to the potential role of human beings in climate change leads inexorably to the question, to what extent are we even allowed to apply a positive discount rate to future generations. I will write down the objective function again to remind you what we did, and then we'll ask the questions of dynamic efficiency and inefficiency. Okay, so the social welfare of all generations weighted by a social planner's scheme will be basically a fairly straightforward question to answer. It involves the present discounted value of utilities of all generations, each applying a private discount rate to their own future, their own second period, their own old utility when old. And then we're going to make this a little bit simple by assuming away technical progress. So this model can be jazzed up in many ways. We'll just set A equals 0 to make things easy for us today. Okay, and we'll derive the social planner's optimum, and we'll kind of write this down in a sort of we'll have to manipulate a couple of first order conditions to get things right, but we'll end up showing that the intertemporal optimality of the social planner should be distinguished from intratemporal optimality. So the central planner does a little bit more than the individual families would do. There is, however, some overlap. So the central planner will actually get it right in the sense of doing what the individual generations, the individual households would have done in the first place. But at the same time, it'll do something more. It'll actually work on the intertemporal margin to make sure that the capital stock over time assumes the right trajectory, which is not guaranteed logically if each household, two-period lived household plans individually. Okay, so let's think about this formally. Think about the following object. Think of capital T generations, starting with 0 and going to capital T minus 1, and summing up those generations' utility, discounting by Xi, which I will eventually eliminate, or substitute 1 over 1 plus theta. And you've also got an issue of the currently old generation. So the social planner cannot just ignore these people. Actually, she could. But when Social Security was introduced in the 1930s, there were a lot of very lucky people. These were the people who were old in 1935 who had no savings. They basically got taken care of. And the central planner has, if she's ethical and cares about all generations, she has to consider these people as well. She can't just ignore them. So this is in there, but it won't play a very important role. So she's maximizing this object subject to a sequence of resource constraints starting in period 0 and going to cap T plus 1. And each of these resource constraints is just the intergenerational, the interperiodic linkage of resources used versus resources available. So the left-hand side would be something like uses, and the right-hand side would be something like sources. So for in any given period, the social planner has the ability to allocate consumption. And again, this is an interesting problem. The social planner doesn't have a market. The social planner, she can do whatever she wants. She can allocate, give a lot of consumption to young people. She can give a lot of people to young people in early years in this program, or maybe do a lot of saving, give it to the people at the end of time. She's basically unbounded. She can do whatever she wants, but she's restricted by reality, by the physics, or if you like, the resource constraint of this equation, the second equation on the slide, which says that basically if she wants to give resources to young and old people today, and she's doing it equitably. There's no reason for her to give a little bit more to certain young people and not to other young people. Her interests are to treat these representative households. That should be pretty obvious. But the interesting issue is the intergenerational and intragenerational differential that she might decide to do for reasons of achieving this optimorum. Okay, so what does she have? She can give consumption per capita to the young. If she wants to give it to the older people, they are kind of discounted because there are fewer of them. There are more young people. And at the same time, we have the same issue with the capital stock accruing. So if you divide this equation through by 1 plus n, you get an equivalent in terms of resources expressed in terms of older person's allocation. Okay, and then you have an initial condition K0, and you have a terminal condition. The terminal condition is an interesting question. If you like, for intellectual discussions of angels on a pin, but it doesn't really matter. We just have to fix an endpoint that will constrain this sequence of one period interperiodic resource constraints to be consistent with one another. In other words, there has to be either nothing left at the end of time, that would be little k t cap t equals 0, or maybe fixing it at some positive level. It's just a terminal condition for the problem, for those who like the technical term. Okay, so I already said that the C is just a set of weights attached to the utility of generations starting at period 0. So if we think of these as relative weights, we can normalize them. We can normalize them so they add up to 1. We can use the geometric discounting rule because it has a time-consistent property. The social planner, she won't have regret once she moves through time that she made the wrong decision, or she won't think, well, maybe I should have redone the whole thing from the start. This is an old theoretical idea that goes back to the 1950s, but it seems to stick with us, and we use discounting, so I'm just going to take it as it is. A positive theta would mean that the social planner cares less about future generations. So this is, again, the issue that Stern raised in the Stern report on the environment. Should future generations be discriminated against in the sense that the discount rate is positive? The ethical point that Ramsey made back in the 1920s was that theta should actually be 0. And if you really take this seriously, if the social planner cares about each person individually, because the economy is growing, you're going to have more people in later years, so you'd actually want to apply a negative discount rate to be perfectly fair. But this would imply a very unusual type of outcome in the sense that we don't observe these days. So the empirical observations, we have positive interest rates. Over history, we've had positive interest rates, and these seem to be associated with some impatience on the part of the decisive agent or the representative agent in this economy. Okay, so we're gonna do a shortcut. We're not going to use the Lagrange approach to solve this problem. Maybe to your relief, you don't have to if you're assured that it's possible to substitute away certain control variables using the constraints that we would normally embody or embed in the Lagrange form. So we have this wonderful intertemporal resource constraint. So we could actually we could remove C1t that's given by that intertemporal resource constraint in terms of C2t and KT plus 1. So the social planner can't do, she can't do miracles, but she can certainly simplify her problem by eliminating C1t, expressing C1t in terms of C2t and KT plus 1. So she would express basically young people's consumption today in terms of her decision for older people today and the capital stock she wants to carry into the next period. And that she has to do, I mean, unless she wastes resources, that's all she can do. That's the best she can do. So doing that, you can substitute, eliminate, and differentiate that large objective function with respect to C2t and kt plus 1, recalling that this is a sequence of control variables. There are two sequences of control variables. So we will have sequences of first order conditions. And this is very important to recall and to burn into your memory, because this is a mistake that lots of students make. Sometimes even PhD students make this mistake. The first order condition in this problem is a sequence of first order conditions. It's actually two sequences of first order conditions. So for any period t, we have this condition holding for t equals 0 to t equals cap t minus 1. And these conditions have an interesting interpretation. We can express them basically. The first one is saying that within a period, the social planner will kind of fix consumption today of the young and the old as a function of their number and the social planner's impatience. At the same time, the social planner will also consider the impatience of the planning family, or the involved family that's only living 2 generations, beta. The second first order condition is an intertemporal efficiency condition, which relates the marginal utility of consumption for the currently young to the marginal utility of agents that are young in the next period. And the linkage there is, the efficiency linkage would be linking these two weights, or weighting these two marginal utilities by the marginal productivity of capital. So this is where the marginal productivity of capital enters in a big way. If capital is very productive, then the marginal product for any given level of capital will be high, and the agent will, or the social planner will prefer to sort of reduce current population, the current young consumption in favor of higher consumption of those same young people, not the same people, but the next generation's young people, giving them a bit higher consumption, given the productivity of capital in the earlier period. So these are called intergenerational and intragenerational efficiency conditions, and the implicit weights are given by the parameters of the problem. How much economic growth do we have? How much discounting, how much impatience does the social planner have? Remember, the social planner has complete altruism for all people in this universe. Then basically the first two terms in the second condition will cancel out. Okay, so that's a very special case, and we think the social planner has some impatience, and we think that there is maybe more likely that generations will be weighted rather than people, but just keep that in mind. That's exactly summarized in this slide. Okay. So the social planner can't. We're going to manipulate these two first-order conditions miracles, and use the intertemporal simplifier problem by eliminating C1t, periodic expressing C1t resource constraints. It's not a budget constraint, because the social planner doesn't have a budget. She has resources. She has the ability to ignore markets. There are no markets in this problem. So this is establishing this benchmark for us to compare private decentralized outcomes with. So how do I want to manipulate this? Let's take the first order condition and let's lead it by one period. Okay, and then we'll substitute that result in the second first order condition and simplify. And the third equation that you see here is exactly the first order condition for the private household planning selfishly in the competitive economy. Okay, if and only if the interest rate, or the gross interest rate, the gross rate of return, or the user cost of capital faced by the private agent is equal to 1 minus the depreciation rate of capital plus the marginal product of capital in the second period. Okay, so in other words, the social planner will replicate the intertemporal decision taken by each agent But this is not enough to pin down the path of the economy over time. And this is where the diversion between the social benchmark optimum and the decentralized economy can actually differ. Okay, so this is because the path of capital is determined by the past. Capital stock is a state variable. If an economy has a lot of capital in time t, the marginal product of capital in time t will be rather low, and with all consequences that might have, it also determines the capital stock in the next period. As long as there's incomplete depreciation, a capital stock is a state variable which sort of has a trajectory determined by its own position in the past. And this is something the social planner could influence, but no individual in a decentralized economy could do, and that's the whole point. So let's go back and consider what would happen if we set A to 0. This is just a special case. We've already set A to 0, but I just want to just emphasize that this is not a central part of the story. The social planner basically will, taking cognizant of the fact that kt plus 1 is also part of her control kit, and that's important to remember, the social planner also will try to get that right. So the social planner can basically decide on the behalf of agents alive and still unborn to steer the capital stock in a certain direction. Okay, so that's her privilege, and that's what makes it very interesting as a comparator, as a benchmark. So it turns out that and I'm going to show this to you, the social planner may be constrained by the initial capital stock for some time, but she will be able to do what she wants over time because capital can depreciate or we can accumulate capital. So basically the social planner it's possible to show the social planner will ultimately steer the capital stock in this planning problem to get it close to what we thought of as the golden rule in the solo growth model as derived by Phelps. Okay, so this would approximately, the central planner will push the capital stock close to a point where the marginal product of capital is about equal, and I'll say why about in a second. You can see what's because the approximation, if you just multiply 1 plus delta times 1 plus n, you have a lot of terms that are second order. If you ignore delta n and 1 can cancel, you get exactly this number, which says that the capital stock should be steered in a direction where the marginal product of capital is roughly equal to the sum of the social rate of discount that the social planner has, plus the population growth rate, plus the depreciation rate. Okay, so if you look carefully at that, you can see that reminds you a little bit, with the exception of delta, or theta. The exception of theta. If theta were equal to 0, if we were in a world where the social planner has no time preference, this would look very much like the Phelps prediction in the solo model, or the Phelps golden rule in the case where technical progress is not growing. So if A is equal to 0. And as soon as we have the social rate of preference, then we could have a diversion. At the same time, you might say, well, what if the social planner cares about all people? Then that would imply approximately that theta is equal to negative n. Okay, and that would mean basically that the marginal product of capital would be set equal to the depreciation rate, or that the real rate of interest would be approximately equal to 0. Okay, so this is the case of no impatience at all, would imply the social planner basically invests to the point where the euthanasia of the rentier has happened, the marginal product of capital is equal to 0. This is a really special case. We're not going to waste much time talking about that. We think that theta is positive, and this means the social planner will choose capital that is consistent with a slightly positive or somewhat positive rate of interest upon subtracting depreciation from the marginal product of capital. Okay, so that's summarized in the next statement. Basically, this golden rule can also be modified to account for technical progress. And so you can see basically this A is very important. It's a very important part of a prediction of what the rate of return on capital should be. And we'll have to look carefully to see if that's also replicated in the private case. Later we'll do a continuous time variant of this model, the Ramsey model, which will actually show that in detail. Okay, so this is kind of what summarizes what I just said. The social planner starts at some arbitrary K0. Central planner, she gets this K0 to start with, she can't change that. And then she's told to maximize utility, choosing consumption and of young and old, and saving the rest, putting into capital in the future. Her optimal path will be to move very quickly to this golden rule capital per capita, this capital intensity, and keep it there for a long time. And this can be shown using difference equations. You can show that the roots are rather low. The characteristic roots would imply that you move very quickly to this golden rule, age level, and stay there for some time before you get off the bus at the very end of the program. So think of CAP T as maybe 200 years. This would be like a social planner planning over the next 200 years. So as I said already, if the social planner has a discount rate of 0, then it looks a lot like Phelps. Phelps said maximize per capita consumption, which was that distance between the per capita production function and the per capita capital widening line. Again, very, very nice linkage to what we did already in the second lecture. Okay, if you want, you can think of the implicit real interest rate, which would be the gross rental rate for capital subtracting 1, and that's just basically the population growth rate plus the rate of technical progress, if we have technical progress. Okay, now this is something I already said before. The presence of impatience by the social planner would imply a positive rate of interest, or more positive than in the Phelps case. Okay, so let's look quickly at the decentralized outcome and remind ourselves what that implies. Consumption at the private level is relating marginal utility today for those who are young today with marginal utility of those people tomorrow. Okay, so this is the selfish sort of me first type of condition. And the relationship of the marginal utility today of my consumption and the marginal utility of my consumption tomorrow, the linkage between that is a race between the rate of return on capital that's given by capital RT plus 1, and that's a decentralized return that's determined by market conditions, supply and demand. We went through that. And the impatience that individual has with respect to his or her own utility over the course of that person's 2-period life. Okay, so if you substitute what RT plus 1 is, you see that it's related to the marginal product, deriving from the utility, from the production function, and it's also got the depreciation rate embedded in that expression. Okay, so that's this equation is known to many of you already. It can be manipulated. You can manipulate it by dividing beta through both sides. And on the right-hand side, you have the gross marginal product of capital, which is like it's gross in the sense of with the 1 on, but it's also respecting the presence of depreciation. So it's the gross rental rate of capital. Can be thought of as the marginal rate of transformation of goods today into goods tomorrow, and you're comparing that to the marginal rate of substitution of consumption tomorrow for consumption today. How many goods are you willing to accept for a good unit of goods not consumed today? And that would be if you look carefully at this, it's a discounted version of your utility you get from consumption tomorrow. How much you'd be theoretically willing to trade off using the beta as a weight for utility deriving from consumption of goods tomorrow. Okay, so here's again, the punchline of this whole analysis is that the benchmark provided by the social planner is not in general reached by the decentralized economy. And this is because the steady state does not imply the same level of capital intensity necessarily that the social planner would like to have. Okay, so if you think of the definition of a steady state means consumption is constant, and consumption and constant meaning constant in terms of per capita across individuals would imply basically that the marginal product of capital is determined by the private impatience. That's the rate of of private discount, which would be beta inverse minus 1 plus the depreciation rate. And the planner would have chosen a different level. The planner would have chosen the golden rule. So again, to repeat, the dynamic trajectory of the capital stock need not be consistent with that implied by the individual decisions of selfish agents planning on the basis of a market price or market prices, price of labor, but especially the marginal product of capital determined by the savings decisions of previous generations. So there's no reason to expect that we'll attain the golden rule level of capital. This is easy to show. So in the section we'll go through an example of Cobb-Douglas production. This type of production function is used in lectures and in teaching, but it's also used in economic analysis because it's a pretty good approximation. It implies constant factor shares. If factors are paid to marginal products, that's the Euler's theorem. So it's a nice example. And log utility function would mean time separability, so you don't have any habit. The marginal rate of substitution for that type of utility function is given by 1, basically. And that's a nice result. So it's kind of a nice. It's easy to get closed form solutions. You can actually do this as a problem set, and you can show that basically you have 2 possible outcomes. One is you're to the left of the optimum, and you're to the right of the optimum. If you're in a sense, if the capital stock is to the left or too small compared to the optimum, then we have what's called dynamic efficiency, because the outcome of private decisions of agents does not elicit enough capital formation to achieve the first best. It is possible to move there, but somebody has to sacrifice. So think of Germany after World War II. There was a lot of mess here, and there'd be quite a bit of investment had to take place. So there was no way you could actually expect young or older people at that period to somehow attain the welfare that Germany was able to reach 40 years later. So they had to sacrifice, and why they did that, a lot of people may have different views on that. But in any case, they had to sacrifice to reach to establish a higher level of utility. If generations are not willing to do that, and you can imagine yourself being stuck to the left of the optimal capital stock, that would be the case of dynamic efficiency. Okay, so it's costly to move, just like in the Phelps exposition of the golden rule in the Solo model. You can also think of dynamic inefficiency, which means we've actually done too much savings, we've got too much capital, and ironically, it would be possible to make us all better off just by eating some of the capital stock. So think of converting taxis into cars for driving, or taking bus seats and putting them in your house, swimming in industrial tanks instead of having using them for swimming pools. Again, this is all very abstract. The idea is clear. I mean, you can certainly reach these types of positions by investing less. And we think we've seen cases of excessive investment in the past. The most often used example of that would be the behavior of the Soviet Union under central planning. There was often considered there was a lot of steel production, a lot of wheat output, but people didn't have anything to eat. So there must be either was wastage, or more likely they just diverted these goods to the wrong sectors and they were never used to produce consumption. Okay, so that's kind of the message that you may have also seen in your undergraduate courses on growth. It's possible to be on the wrong side. And these are the interesting cases. The dynamic inefficient cases are the ones where we think a government intervention might actually make everyone better off. So there should be very little political resistance to this type of situation. It's harder to imagine a government intervention that would move us from a dynamic efficient situation where you're not at the best of all possible worlds without having some sort of government bribe for currently young people to save more in the interests of getting on the right growth path in the future. Okay, so let's think about some interventions that might actually induce moving an economy to move towards a better place. Possibly not. Possible that the intervention may actually worsen things. So again, to be completely fair, and we'll use the apparatus of the last lecture to think about this. We'll use this to think about several different possible policy situations or policy problems. One has already been mentioned, which is the provision of income to old people. One might have the view that the system does not provide properly for older people. Most of what is often thought of is inefficiency at the micro level. People are poorly informed, or they're not quite rational enough. They don't plan for their future. Maybe they've had some bad luck. In the macroeconomic sense, many of these things wash. What we're really talking about are the global incentives that produce more or less savings on average. We'll talk about that. We'll talk about the possibility that asset bubbles, I'll just mention this, but if you think about it, the capital stock and the diamond implementation of the Samuelson model says that capital is used as the vehicle for savings, but you could just as well imagine the Samuelson version where money is used. Later on, we'll talk about that in this course. You could also imagine other types of objects that people consider to be valuable for whatever reason. You could think of gold or housing. Housing is kind of a type of capital stock, but you might think it's somehow special because you derive some consumption from living in the house. You might think of jewelry or pieces of paper, tulips. So you might think of asset bubbles as actually serving this function of absorbing some of the savings without necessarily implementing or affecting the capital stock, which is used for production. Okay, so I'll just mention that briefly. You can also think of government debt in the same way. Government debt is kind of an extra asset that people can use to save. We'll talk about, in detail, we'll talk about altruism. So possibly the concern that you have for your children, should you have any, will affect your willingness to save and dissave, because you might be interested in giving your children some assets that they could would change their potential savings decision in your interests. So in other words, making yourself happy by making your children do something that makes them happy. Again, the symmetry of the problem, the intergenerational symmetry is important. We're kind of assuming that parents and children are kind of replications of themselves in this intertemporal sense. The world gets very complicated if you think your children are just unmanageable or different. No comment. So let's do the policy analysis on the pensions first. So I'm going to distinguish between two different types of pension systems. One is funded, which means that it's based on the capital stock. In a sense, you might say, well, this sounds like the government's just doing what the private sector would have done anyway, and that's probably not completely incorrect. Especially if you consider the reason that the government does this intervention, the reason why Bismarck implemented the Social Security system in the 1880s in Germany was to provide for people who got it wrong or were unlucky, they lived too long. So back then the life expectancy was probably about 60 years. So if you managed to be unlucky and live till you were 65, the government kind of said these poor people, they're unlucky. Even if they save, they kind of run out of money, and we have some desire to help these people in their last years. Back in those days, very few people actually lived to that age, so this was not a very costly system. But you might still think that people don't get it right. People, even though they have information, they still might just behave in an irresponsible or different way. Maybe they had some bad luck and are living on the street. These are all things that we have to worry about as a society. At least some people think we have to worry about them. And if that's the case, then these systems might exist. The government might just tax from the young and put it in a fund. Okay, so think of maybe Norway, think of a country or Chile or Netherlands, where they tax and invest a lot of this money in either government debt or even in the capital stock, even in just buying stock, which is not such a outrageous thing in the end, but you might think it's unnecessarily just a replication of what the private sector would have done anyway. Well, on average, maybe, but not in particular. So if this is the case, again, macro is about averages. So the equilibrium in this case would involve the private sector considering this lump sum tax. It's not based on decisions that you're making. It's a very important aspect of this problem. In this particular example, the government just takes tau from you when you're young and then puts it in some sort of magic machine and generates BT plus 1 for you in the second period. And the question is, of course, how does it do this? What kind of magic machine does the government have? The government doesn't have any sort of special technology. It has basically the asset market, or has the capital stock. It has access to using the same aggregate production function that private individuals would have. And if that's the case, the first order condition for the private household would involve equating marginal utility today to marginal utility tomorrow, appropriately discounted, scaled up by the value of the investment, which is RT plus 1. This is a perfect foresight model, so you can see that this is pretty much the same thing that the aggregate economy would do. So even though you might have some people making big mistakes one way or the other, the first order effect would be summarized by that first order condition. So the government does what households would have done anyway. So why do it at all? I said it already. Maybe there's some individual uncertainty. Maybe there's just concern for the people who fall through the cracks, and that's fine. But in that case, we can use the picture from last week, the figure, and remember the blue curve is the factor price frontier, tracing out possible combinations of wage and net rental rate on capital, also accounting for depreciation between between wages and rate of return. This is a negative relationship we derived in the second and third lectures. The red curve is the goods market equilibrium condition, which basically determines the interest rate tomorrow as a result of investment decisions, savings decisions that were taken in the previous period. So it's the marginal product of capital tomorrow is a function of capital tomorrow, which is the savings decision taken by agents today, adjusted appropriately by the rate of population growth. Okay, so this is kind of easy stuff. We've done this already. The interesting thing is what happens if the pension system is not based on capital. It's not a funded system as it is in many, but not very many countries in the OECD. I should note that originally the United States pension system was not pay-as-you-go. Government, there was a fund, a Social Security fund, which was quite large, and it was basically investing in U.S. Treasury securities. So you might say, well, that's kind of a swizz. You're using people's contributions to buy government debt. Well, it turns out that the aggregate is what matters. Okay, so if the government's borrowing money from the private sector, that's one thing. If the government's borrowing money to fund its pension liabilities, that's perhaps a better thing. It could also be doing a complete Ponzi scheme and borrowing money to run a deficit on the government's current account budget, in its budget, and also tell the people that future young people will pay the pension of the current old. And that's what we're going to talk about. So we're just going to consider a pension system that's called pay-as-you-go, which is what the U.S. Does now. Okay, there is still a Social Security fund, but it's much smaller because in the 1960s, some say to fund the Vietnam War, President Johnson sort of pillaged this fund. This is, I can't prove this, and I'm not going to bother, but if this is a classic case of the government sees this big bag of money there. What is it going to do? It's obviously going to put it to work for you. So think of Social Security as being potential temptation for the government to take contributions by young people and actually not invest them. Okay, and sometimes you could actually just go outright. In Germany, we talk about a Generationsvertrag. It's just an explicit agreement. Young people today work hard to make sure that older people today have resources to live on, but with the insurance that when they get to be old, there are some young people around who will pay into their system. And as long as that belief is sustained, this model is completely sound. Okay? So you can also think of population growth, maybe importing a few people from abroad would help, or getting some technical progress, in the general case, would help feed the pension system over time. So here the private first order condition is kind of the same, but the problem is that B, that's paid to the currently old in the second period, is not necessarily related to the marginal product of capital. Okay, so that's the key insight of this condition. So now the private first order condition, I mean, it has this BT, but BT plus 1 is no longer determined by the policy of the marginal product of physical capital in the capital markets, because the government is not taking the contributions and investing them on behalf of its citizens. It's actually just giving it to the currently old. Okay, so this means that the effect of that intervention is to move the goods market equilibrium curve to the right. Okay, and that means that aggregate savings, the sum of aggregate gross savings by young people and the dissavings by people who are old, is not constant anymore. Okay, it's going to be lower because the current old will be receiving a income from the government, which is paid for basically not from the rate of return on capital. It's paid for by contributions of the following young generation. So as a result, the curve shifts to the right, and every wage interest rate combination that was consistent before has to be, every wage before has to be associated with a higher rate of interest in the steady state. Okay, so think of this as a rightward shift, and therefore the green dot that was previously the equilibrium in the upper left-hand part of the diagram will now move to the lower part. So we have less capital, we have less savings, lower productivity of labor, because labor's marginal product is determined by the capital intensity. We saw that in lecture 2. So lower capital per capita means lower wages. It means the capital is scarce. Okay, so the rate of return on capital, the net rental rate of return on capital will be higher and rises to R prime. Okay, so in the diamond model, the introduction of a pension system will affect the real economy if it's pay-as-you-go. In this particular case, the capital stock drops for sure. In the case of the pay-as-you-go system, and whether or not we move to a higher or lower consumption per capita depends. So it's not even, we know for sure that capital stock will decline. That's pretty much a given. That follows the logic of a pay-as-you-go system. But whether consumption rises or falls per capita will actually depend on whether we were dynamically inefficient or efficient before the system was introduced. Okay, so again, recall this is the original intervention. We have not identified the efficient golden rule, social planner's optimum, if you like, modified golden rule in this diagram. So we need to do that. Okay, so you can imagine two possible outcomes. You can imagine the possibility that we were dynamically efficient. So moving to a pay-as-you-go system from a fully funded system would actually make capital move away from its golden rule level. So wages would fall relative to where they were before, but they will be even farther away from their golden rule level. And the capital, the rate of rental rate on capital will be higher than it was before, but it'll also be even farther away from its golden rule level. So this is a bad idea. If you thought the United States was dynamically efficient when Social Security was introduced and the U.S. was saving too little to begin with, this means the U.S. is definitely worse off after the intervention. Okay? But that need not be the case. It may actually be the case that the economy is saving too much, and therefore the economy is not consuming enough given what it could be consuming. When you're in a dynamic, inefficient situation, it's possible to uniformly reduce the level of consumption of young and old in every period from now until the end of the program, and not, to reduce savings, to reduce the capital stock, and thereby increasing capital, increasing consumption per capita of young and old in each period from now until the end of the program. In effect, a free lunch. Okay, so this is being on the right-hand side of the golden rule in the Solow-Phelps diagram. So this would be implied by having, as you see, the gold, the omega gold is the lower wage, R gold is the higher capital stock. We're saving too much. The intervention would move us from omega to, say, omega prime. So we're getting closer, if not actually on the golden rule level of savings. And remember that the slope of the factor price frontier at the point of intersection is the capital labor ratio. So the implication of moving from omega to omega prime means the capital labor ratio declines. Less savings per capita, less capital stock per capita, and yet the nation, the country, the economy is better off because there's more consumption. The presumption is that consumption is what makes people happy, not the volume of machines, productive capital per capita that you have. That's a very important insight of this model. Now, of course, it's possible that pay-as-you-go has other aspects that are not considered in this OLG analysis, and I certainly would like to mention a few of them. The population growth rate of a country and the country's rate of technical progress are not constants. They may change. So one could imagine that as we move through the decades, that technical progress can decelerate or can accelerate. At the moment, we think we're facing a period of technical slowdown, even though we have lots of technology. We have iPhones and fantastic internet, and we can watch Netflix all day. There is this view that maybe this isn't contributing as much to economic growth as previous innovations like steel processing or automobile manufacture. So if you believe that, this could be a variable and not particularly well forecastable, but maybe in a sort of a very slow sense, we can say that for the next few years we'll have a lower A. Then you can work through the comparative statics, and you'd see that that would imply that the economy might actually move away from its welfare optimum as a result of these changes. We can also think of population growth. That's probably more interesting example. We know there's been a demographic shift in Europe over the past few decades. Europeans are reproducing at a lower rate. There are many places where there's a shortage of labor, especially skilled labor, but in general. And if that's the case, that has implications for the interest rate as well as the social optimum level of savings, et cetera. So because of all these risks, you might want to actually consider having a multiple pillar system. This is the European way. There's a public system, a public pay-as-you-go system, which everyone has access to. There may even be a minimum pension. Then there's a second part that might be funded by publicly regulated private pension systems that are offered by companies. Betriebsrente in Germany or America, you have the tax subsidized private pension arrangements that you can do. Some professors have access to a system that can be transferred from one university to the next. It's all backed by assets. Then you can also think about the third pillar being just private savings, not tax, not particularly favored by the tax system. You might be able to have a tax advantage on investing in certain types of funds and pulling the income out later and paying the tax rate that's applied to your income when you're retired. Many countries have played with moving partially or even completely to a funded system. It's politically very difficult because when you do that, you're asking the currently young to forsake what they were expecting to have when they were young themselves, and maybe now are getting old and they're saying, well, I'm not going to give that up. Or you're asking them to pay twice. You're asking them to pay the currently old, and you're also asking them to save for their own future system. So it's often associated with political discussion, if not infighting. And of course, if you move to a capital-backed system or to an asset-based system, funded system, you have to worry about the marketability of the assets, the ability to convert the assets into consumption. And we do this through the stock market, and if the stock market crashes, this means that people, crashes tend to be undone after some time, maybe 5 to 10 years, but during that period, the persons who had saved and are ready to retire may find it difficult to go back to access those resources, and may have to stay in the labor force for several years. This was the case for many Americans after the financial crisis, even though the rate of return on assets in the United States, on capital assets in the United States, is, even adjusting for inflation, is 6 to 7, 8%. It's often not, it's not completely easy to move resources from that system at any point in time, because you might have a period of low valuation of those assets. So let's continue the last couple of interesting applications. I'm going to talk about government debt quickly. Government debt would also serve as a kind of a way of getting away from dynamically inefficient equilibria. So that's the logic. I mean, if the economy is saving too much, if the government runs a deficit for several periods, it could actually it could do something with that money. It could actually buy output with it. It could transfer money to other people. It could basically inject its assets into the system, and people could buy those assets. Only the young will buy those assets, because older people have no use for them. They're not going to be around. And then the government, you could make the assumption the government has to pay the interest rate on capital to satisfy investors. There's no way you can make people do this. They have to do it voluntarily. Then it's possible to show that basically the private intertemporal budget constraint in a sense, is, as an aggregate, has no effect, okay? But the interesting issue for the economy is how do people consider this? So you might think that if the government is just taxing the old to repay the debt coming due, and we're in a dynamic inefficient situation, then the economy could literally move towards a more efficient level of capital formation. On the other hand, there are many things that could also intervene. We'll talk about this in detail next lecture, but even in the presence of dynamic inefficiency, there's some interesting issues involved. And if you think that governments are dealing with agents that are that have intertemporal altruism at the same time, like we had last time, I'm going to talk about in a second, the government may actually also have to deal with the fact that agents will do things to offset their implicit tax liability in the future. Okay, so if you think you're going to be taxed in the future, you might just say there's no effect at all, so we owe it to ourselves. And then there's some other distortions that may arise. The government may waste money instead of transferring it. It may tax and distort economic decisions. It might also have a situation where interest rates are different. Okay, so I'd like to get into those details. It's interesting to talk about a benchmark which says that the agents simply look at the government budget constraint and internalize it. Okay, so again, this is a fascinating issue that was raised by David Ricardo. This is most interesting if you think of an agent that lives a really long time or lives exactly one period. Think about getting a tax cut today when young and told you're going to get some money in the future. If the government took your tax money and put it invested in the capital stock, you'd be basically getting what you would have gotten anyway. Okay, so that's the logic that Ricardo had. And Barrow went on to show that if agents live in a world of overlapping generations and yet care about their future generations, that maybe even this logic might extend to very, very long periods. So even if you're kind of selfish, but you care about your children, and you know your children are going to pay taxes that are going to be raised because your taxes were cut, then in some sense debt will have no effect. It won't enter the budget constraint at all because it's all internalized. Okay, so you can see this by just thinking about the logic of government debt. Think of government debt divided by GDP the same way we divide, we normalize by things that are growing. The debt to GDP ratio is a great measure of sustainability. We'll use this later on in many courses. And if the rate of growth of debt, the debt stock without any sort of payment of capital, payment of principal is growing at the rate of R, and the rate of growth of output is basically our solo model, which is A plus N, the rate of technical progress plus the rate of population growth. And if the golden rule is R equals A plus N, then it's possible that debt could move an economy towards a more efficient golden rule. Otherwise, it will probably reduce welfare. Okay, so I mean, the government might actually have a better interest rate. It might have an advantage. And if you look at these excerpts from The Economist, these are different years. You see that there's a fair amount to that, especially since the financial crisis. Government debt yields much less, has a lower rate of interest, if you like, than corporate bonds issued by the private sector. So the government has a financing advantage. It can borrow money at a better rate than the private sector. So David Ricardo was describing a very specific case when he thought about a person within her own or his own lifetime getting a bond issue, facing a bond issue by the government, or a tax cut by the government, and asking what would the government do, how would the government finance that? So if it's a tax cut, the government could finance it by raising taxes one period hence, or if it's a tax increase, the government doesn't change anything, the government invests the money and gives it back to the agents in the second period. Then you think of the government facing a very similar intertemporal budget constraint to that faced by by the private sector. But if you read Ricardo, he actually says this is probably unlikely there'll be a complete offset because, indeed, the government might have a better interest rate, or there might be other considerations. But Ricardo's idea was picked up by Burda, and we'll see it in a second, how important that is. If indeed there is a intergenerational altruism, this would be one way of thinking that maybe the equivalence of tax cuts today with tax increases tomorrow by the government, or the irrelevance of debt is a proposition that one needs to take seriously. Okay, so I'll finish up by making that more concrete. I'm going to talk about the implications of altruism for this problem. And I'm going to motivate it by thinking about this gentleman who is the kind of the father of a lot of the analysis that we will do. This is Frank Ramsey, who was an economist who lived only 26, 27 years, but managed to make several contributions, fundamental contributions to economics. He was also a mathematician and a philosopher. He was an extremely gifted mathematician. He was the wrangler. He was like one of the top math performers in the Cambridge Tripos examination in 1923. Okay, so he wrote 4 papers. I think all are considered pretty important, but 2 of them are in economics. And one involves taxation, how governments should tax goods, completely orthogonal to this subject, but the idea that the government should tax goods for which the demand and supply are relatively inelastic to reduce the amount of loss of consumer surplus. More important for us is the Ramsey rule, which is the behavior of optimally planned consumption over the program that we've just been describing, but in the infinite horizon. So in the next lecture, we'll introduce that problem. And if you read this obituary, you see that John Maynard Keynes thought quite a bit of this this scholar, and because of his mathematical prowess, but also because he was able to use the math in a creative way to interpret an economic problem. So I won't read that, but it's a beautiful tribute to this guy. This is from his obituary in the Economic Journal in 1930. Okay, so why is Ramsey important? Ramsey was discussing how we deal with future generations. They're not born, but maybe they're related to somebody who's alive today. So if they're connected individuals, the problem sort of changes its color a little bit. It becomes a bit more difficult to understand. We all sort of are connected to somebody. We all have parents. Parents may not be alive anymore, but this type of connectivity means that people may act not just in a selfish way, but they may be altruistic. And of course, you have all sorts of other issues. What about immigrants? They come in, they also have connections, but maybe their connections are abroad. Maybe they're sending money to abroad. Maybe they will have children who will live in this country. And this issue impinges directly on the choice of social discount. So what should the social planner do in this case? Okay, should we treat individuals equally, or should we treat generations equally? And Ramsey, back in 1928, in the true sense of a moral philosophical question, thought this was worth discussing in detail. Okay, so I'm gonna motivate this by in the following way. I'm going to think about, and this is kind of made very transparent by Barrow's paper and subsequent papers, thinking about agents' utility in the following way. No longer do you have utility over C1 and C2 consumption today and tomorrow, but you're also altruistic. You care about the utility of the next generation. So we're not going to have families and the rest. We're going to think about people just caring about the next generation, and therefore V immediately has a recursive nature. VT is going to depend on VT plus 1. So no matter how VT plus 1 is determined, it's going to enter the utility of agents planning at time t and being young, okay? So again, subject to the private decentralized budget constraint that we already know, and thinking about B as a new choice variable. This would be the bequest that an agent receives. So BT would be passed from older agents to the currently young, and the currently young can pass a bequest on to the next generation. So BT would be an inherited bequest, and BT plus 1 would be a decision variable for the agent. Okay, so you can actually substitute this back into the problem, eliminating BT, and you end up getting something like this. So you end up getting, in a sense, an agent. If the agent could actually force future young people to do what the current agent wants, then the agent would be maximizing some sort of social planner's problem. It's a little bit different, obviously, because beta still appears. Well, it appeared in the other problem as well, but we don't really have a guarantee that theta is going to be the right theta. So it may be the case that if we impose conditions on theta to make it look like the social planner's theta, then we'd get very close to the social planner's optimum. And of course, there's always the problem that you may not be able to control people's decisions in the future. This problem is there's no control guaranteed, because I can have utility over future generations, but I may not be able to do anything about it. So the way to think about this would be that I'm going to try to do something about it, knowing that the next period's utility is going to be the exact same problem that I'm dealing with today, but it's going to be taken by another person. So all I can do is influence that person by choosing the state variable that agent will inherit in the next period. Okay, so we'll use the bequest as a control variable. And Ramsey didn't write this problem down, but this is a way of motivating the Ramsey idea, because the motivation comes from more modern analyses, for example, by Barrow and by Philippe Vale and others. The agent will basically understand that future generations have the same problem, face the same optimization problem that the agent currently faces, having inherited BT. So you could think of V star as a sort of what we call a value function, which is the optimized value of utility given the state variable BT, and choosing BT plus 1 as a control, and also using using the other tools to solve that problem, using the conventional budget constraint as written down here, and the important insight here is that V star is a function which is not time dependent. Agents basically behave as if future generations will behave as in the same way they behave today, and the only difference is the state variable that sort of drives the utility. So obviously V star will be a positive function of the bequest that the agent receives. Okay, so you can show that this function is actually increasing in concave in the inheritance that you receive today, and therefore you can incorporate that insight into your own optimization problem, and you can actually show that it's possible that generations taken collectively will actually replicate the social planner's decision, as long as you don't need to make a negative bequest. Okay, so the way you can sort of motivate this is just by thinking about writing down the problem in the following way, and showing that by substituting, the first order conditions for each generation actually reflect the same first order conditions that would have been chosen by the social planner. Okay. It is important to remember that each generation has a certain amount of intertemporal, the intertemporal weighing of utility, which is given by a theta, need not necessarily be the social discount rate implied by beta. Okay, but in any case, we can actually show that you can replicate this, this idea of Ramsey. And you can show this by just manipulating the first order conditions. And using the fact that if you differentiate this value function with respect to bt and apply the envelope theorem, which means that you won't change your policy variable given the state that you're in. This implies that that there's a relationship between the marginal utility of an additional increment to the inheritance received in period t in relation to the marginal utility of receiving that inheritance in the next period, a generation receiving it in period t plus 1, involving the rate of return on savings. And just by substituting and leading would result in the same first order condition that we had before. So we ended up having the same type of optimality condition for the dynastically planning family that the social planner would have chosen in the first place. Okay, so when the household behaves dynastically and has the access to or has the same intergenerational weighting of utility we call theta, then it will actually replicate the social planner's problem. Okay, so I've basically touched all the bases for this problem. I think it should be clear that it's a difficult one, but the insight of this discussion must be that it's not correct to consider each generation acting completely selfishly. And if you do, you reach a point where you actually see that there are large pecuniary externalities involved. At the same time, if there's some extent of intergenerational altruism, it's very likely that we'll move towards a more socially optimal or more socially optimal solution. Whether we get there or not really requires that the altruism of the agents intertemporally reflect those that would be chosen by the social planner. So there's still potential for a bit of selfishness that would bring us, would take us away from the social optimum chosen by the social planner at the beginning of the lecture. Okay, thanks, and I'll see you next week.